I'm Darius, and I'm the CEO of Raincode, and I'm so happy to have you today with us. There's a lot of content available out there making promises about what any given technology can do, but we really wanted this webinar to be different. Instead of going through yet another list of bombastic promises, we decided to focus on real-world stories, on what technologies has delivered for real people, for real companies, for real projects. And as our guests will demonstrate today, the variety and range of problems people face when migrating off the mainframe are just amazing. It's the very opposite of the concept of one size fits all. Each and every one of these projects is different. Before we proceed, though, just a word about the format. We kept the presentations short and to the point to make this webinar easy to follow. Please leave any question or comment you may have in the chat, and they will be addressed during the Q&A after the presentation. But enough of all that. It is my honor and pleasure to give the floor to Uli Homann, Corporate Vice President at Microsoft, for his take of what a cloud native future may look like. Uli, the floor is yours.
Thank you very much. I really appreciate you, A, organizing this great event, and B, inviting me to be participating in it. Let me get my slides up. Give me a second. And now let's hope that we can see it. I assume we can. All right. So now let me talk a little bit about the cloud native capabilities. So I'm the exception to Darius's rule, where I will effectively talk a lot about not promises, but technology investments that we're making that are not proven yet per se, but that are certainly emerging as the way to move things forward. So I will give you a perspective on cloud native, because cloud native is obviously the way the world is moving forward. And if you are looking at cloud native, you need to think about applications are being developed now that we haven't seen before. We have seen applications obviously throughout the decades, but now we are seeing applications scale to unimagining numbers on the one side, meaning lots and lots of scale, but also scaling down when the resources are not needed. They're going down to the minimum amount of resources to service whatever the customers at this point in time need. And we now need to think about how do we implement those in this kind of capability, and how do we then build the assets that we have built over the years, how do we make them into this part of the cloud native capability? And obviously that's what this conversation is all about. Now, let's define what is cloud native. If you are following, go to slide 4. This is it. Yes, thank you. So cloud native is a set of concepts that the world has adopted as being part of the conversation of how you build applications for the future. The first one is more of a conceptual piece where you say we're going to have microservices, which are effectively small parts of code that are contained and managed in a consistent fashion, so that you have a fast change velocity, but also a small change vector, rather than monolithic applications that have a large surface area and that are hard to change. Now, if you think about building those microservices, you hear the terms DevOps and you heard the word container. So DevOps is the process of how you get to this capability of building smaller services that are agile and fast to change, fast to deploy, and fast to effectively learn from. And then containers are the way for people to package those applications and distribute them into the operating environment, be that a cloud, be that even a mainframe these days, or a on-premise environment. It doesn't really matter. All environments these days really support containers. With the triangle of microservices developed by DevOps, packaged by containers, you already have a very, very solid foundation. What's happening in addition, though, is that the world is moving to an API-first model, and APIs are really an expression of functionality that other people will build solutions against. And then you're adding a new programming paradigm that's called functions or Lambda, depending on which cloud environment you're on. Google and Microsoft call it functions. AWS calls it Lambda. But the idea is that you have a piece of code that reacts to external stimulus, mostly driven by events. Could be an HTTP call, could be an event from a storage system. And that piece of code gets woken up, runs, and then goes away. So this idea of a serverless operating model where you don't even think about packaging code, you just load the code into the cloud function. The function knows which triggers effectively go and activate it, and you then go from there, driving it forward. So from that perspective, it's really important to think through how your strategy with new code and existing code can take advantage of this set of capabilities that are really turning the world upside down. Just to give you an idea of why this is important, I have worked, or Microsoft has worked with customers in the e-commerce space, for example, where a customer using microservices and containers and Kubernetes as the next generation infrastructure was very happy that they were able to deal with the Black Friday surge of requests and demand. They were able to move to meeting the demand and doing it for a fairly affordable price, way cheaper than what they had been able to do before. The interesting thing, though, is that a similar retailer built the solution also on microservices, but augmented the capabilities with events and functions. And they were able to deliver the same kind of scalability, meeting the demands on the Black Friday retail environment with far less money. Because the functions are much smaller, much faster to run, and they only get built by the seconds they run. So composing the capability against this picture is really one of the areas of investment that everybody needs to think about for existing and for new code. How do you augment existing code with capabilities? And our Raincoat friends have done an amazing job taking the mainframe assets, be that COBOL, PL1, or assembler, and augmenting them with modern functions, with being able to integrate in a microservices function-oriented world, and being able to deploy code in containers, participate in DevOps, and so forth. Now, let me talk a little bit about what all these pieces are. As I said to you before, you're seeing a cloud-native architecture. This example is on Azure, but you will find similar capabilities on all the other hyperscale environments. And we, as Microsoft, are investing deeply in all of these components because they effectively form the nucleus or the foundation of where investments are going to go in the future. How do you go and build these capabilities, scale them, bring them up and down, and also distribute them where you need them, because Azure might be your favorite place, but you might have on-premise environments, or you have investments in Google Cloud or AWS, and how do you effectively build code that then can take all of your operating models, be that, again, multi-cloud or on-prem, and run where you need to run them. And again, I'll show you a couple more examples of how this works, but wanted to give you a picture of how all of this can work using the example of Azure as the hosting environment. Now let's talk a little bit about what we are investing in to make life easier. So Azure Container Apps is a very new investment that we have made based upon listening to clients and customers about Kubernetes being a fantastic environment and certainly the investment of the future, but also not being the easiest to work with, and really challenging application developers and operations team with complexity that is very rich from a flexibility perspective, but it certainly challenges customers with respect to their know-how. Now we've built container apps to help developers really focusing on building applications rather than having to worry about how does Kubernetes work, what are the right investments in scaling Kubernetes up and down and so forth. And this container apps is a environment that we have again built to help you abstract some of the Kubernetes complexity or richness, depending on how you look at it, and have the developer focus on container applications. And I don't know if my friends from Raincoat will show this today, but we have been working with the Raincoat team to effectively go and have the assets that Raincoat can build be hostable inside container apps. And container apps allow us to then be available anywhere you want to be, meaning on Azure, on AWS, on GCP, on premises in a VMware, bare metal, Nutanix environment, and so forth. Simply building applications that can run wherever you need to be able to run them. And again, our friends from Raincoat have been doing some great work there. I hope that they will show it as part of this conversation. The next level that we have been investing in, now that you have an infrastructure called Kubernetes, you have a simplification model that deals with some of the richness of Kubernetes and simplifies it using container apps. Now you can say, how do I build or extend existing applications so that common problems like invocation of service to service are becoming effectively solved. And there is a CNCF, which stands for the Cloud Native Compute Foundation project, an incubation project called Dapper, the Distributed Application Runtime. And Dapper effectively allows a application developer to take a dependency on, for example, secrets management or observability management, and be then trusting that the hosting infrastructure, be that Microsoft Azure, AWS, Alibaba, or Kubernetes, effectively providing the necessary implementation so that you as a developer can focus on your code, requiring a certain set of functions, and again, being able to utilize the native hosting environment. So for secrets management on Azure, for example, you would use Key Vault. On Kubernetes, there is a Kubernetes native secret store that you would then be able to utilize, and you don't have to change your code, which obviously is important. And again, there is a very cool demo that Darius and team built of how you can extend and utilize your existing mainframe code using the Raincoat applications and bring Dapper functionality in so that a piece of Python code using the service-to-service invocation, for example, can work with your existing COBOL code as if it were a native function. So a really cool way of thinking about how you build applications. So now we have seen three pieces. We have a common infrastructure, Kubernetes. We have an abstraction that effectively allows us to build applications faster using the rich capabilities of Kubernetes without having to worry about the details, called container apps. Now we have an API surface that deals with common application scenarios that allows us to bring new and existing code together in a consistent fashion, while at the same time being optimized for whatever the hosting environment be that Azure, be that AWS, and so forth. Now, the last piece is, how do I take application capability that might not yet be reaching standard or that is proprietary to a specific environment? Now, Microsoft has been investing in Azure application services like App Service, Azure Functions, Logic Apps, and so forth as part of our Azure application and cloud native investments. We're now taking those investments and making them available on top of Kubernetes, so that your applications that take advantage of Azure native functions like Azure Functions or Logic Apps or API management can now take those capabilities and bring them into a Kubernetes environment, which means on Azure, they run as serverless operated environments. On GCP, AWS, VMware, or whatever the environment is, as long as it can host a Kubernetes cluster or a Kubernetes environment, they can run inside that function. What that means is you now have rich cloud native functions from Microsoft that can now run anywhere. And composing this together with Kubernetes, container apps, Dapper, and now you have Azure Application Services, you can build cloud native applications that were previously only available in a specific environment, be that Azure, be that AWS or GCP. Now you can have this wherever your code needs to run, be that inside a factory, be that inside a retail store or on premises or across multiple clouds. And we believe that combination will help all of you to build these cloud native applications, bringing existing assets using the Raincoat innovations I referenced throughout the conversation, and modern assets that you're building from scratch together to really form the next generation application capabilities that you need in order to really compete, be flexible, be agile, and drive it from there. So with that, I want to bring the conversation back to Darius and team, but appreciate the time to be able to share a little bit about what is cloud native, how are we responding and driving investments against this, and I'm looking forward to the rest of the webinar. Thank you.
Uli, thank you. Wonderful as ever. That's the problem with you. The expectations are such that they are very, very hard to meet, but you did wonderfully. Now it's really my pleasure to introduce Pierre, who is Associate Director at Accenture Poland. And Piotr is involved in one of the most amazing mainframe migration projects. And well, he's going to tell us tons of things about it. Piotr, the floor is yours.
Hello, everybody. Thank you, Darius. I hope that everything is visible. Can you see my presentation? Okay. So, hello, everybody. Today, I'm going to share with you the story of replatforming of a large mainframe system. Usually, when you hear about replatforming, you encounter cases with hundreds of MIPS, or you encounter cases with thousands of MIPS, but you might be wondering whether it's possible to replatform a system with 10,000 MIPS or 20,000 MIPS or even more. And the answer is yes, it's absolutely possible, and this will be the story about it. So first, let me say a couple of words about our customer. This is a large universal bank in Central Europe, and this story is about replatforming of their core banking system. The core banking system is usually the heart of IT landscape for every bank. It is processing accounts, loans, millions of transactions every day, must be available 24 hours by 7, and must be available real time. Our customer has over 10 million customers, all segments, retail, small and medium enterprises, as well as one of the largest corporations in Central Europe. It processes over 20 million of current accounts together with their transactions, whether they are financial or non-financial ones. From the technical perspective, the system is over 20,000 MIPS, and the traffic that is generated by the customers, be it mobile, internet, or branch, is well over 3,000 CICS transactions per second at peak. Before we jump into the project, let's think for a while what a mainframe replatforming with Raincoat is. So first, you take your COBOL code that you coded and you developed over the last 50 years with all the precious business logic that you have. You compile it with Raincoat compiler into .NET executable files, and then you run it on Windows or Linux server. So it's as easy as that. Of course, mainframe application is not only about COBOL. It's also about maintaining running your batch processing, file sorting, monitoring, and scheduling. So you will need other Raincoat and marketing tools for file sorting, monitoring, scheduling, and so on. In our case, we are using Raincoat JCL Raincoat batch stack to interpret JCRs and to process them. We are using DMX for file sorting. We are using Kibana and Elasticsearch for monitoring, and also Automate Now for scheduling. Of course, you also need to think about target database. So in our case, this is DB2 PureScale for Linux, but you may use Microsoft SQL Server as well. Finally, you can enjoy your app on open platform, liberated from your old good mainframe. So much for mainframe replatforming. Now, why is it good to think about replatforming? You may say that there are other ways that you can change your app. This might be either rewriting the application, or this might be implementing a new system. Well, in general, usually these two ways are far more expensive and riskier for organizations and for the people that run the projects. In case of core banking system replacement, it means really huge funds, huge project, and the risk that in the end everything can fail. Half of core banking transformations usually fail, so the risk is really high. And this is the reason why it is better to do replatforming instead. And let's go through details. So first, replatforming is possible and can be performed in a safe way. Absolutely, this is a safe way to transform your system, and the risk that something fails can be really limited almost to zero. Second, with replatforming, we can build appealing business case. The platform cost cuts range from 30 to 80%. In general, the more MIPS you have, the better the business case can be delivered. Replatforming also lets you to retain your IP and lets you retain your current business logic. So if you are implementing a new system, usually you will not have the IP rights, and you will also face a new business logic, which is very often standard and not as complex as what you have built over 50 last years. And you will have to make decisions whether you want to customize heavily the new system or whether you abandon this business logic. Replatforming is also a significant transformation with no impact on business departments. What it means, if you implement a new system, your business people will be heavily distracted from business. They will have to analyze the system, identify gaps. They will have to document requirements, sign off them, then go through acceptance tests, and at the very end decide whether what has been built is what they really wanted. When it comes to replatforming, it's far easier for them. They are almost not involved. Then they can concentrate on business. And in case of replatforming, they are actually passive investors looking forward to benefit from future positive cash flow. Replatforming brings no impact on business functionality development. So if you have a new system implementation, you cannot afford to have a moving target and to chase it. Instead, you rather limit development of the old system, and at some step you need to stop it. So that means that your business cannot develop. This is completely different while you are doing a replatforming project, because you can deliver business functionality with almost no limits during the project in parallel to it. Well, that's trivial. Replatforming is a response to labor market. It's difficult to find young people who want to work with mainframes. I would say it's almost impossible. So if you want to be attractive for young people, you have to do something with your system, and replatforming is one of the ways. It will be far easier for you to attract new people, young people, and make your system being maintained. Replatforming also allows you to enter new platform technologies like cloud or DevOps, and this will allow new possibilities and future cost savings. That's also trivial. New development tools and DevOps will allow agility and time to market. So that's something that is very important today. Last but not least, Raincode offers native interoperability, which means that COBOL components will be able to call .NET ones. The .NET components will be able to call COBOL modules, and this will be without any middleware. So just think what it means to your team. You will be able to recruit new workforce who usually have pretty good .NET skills, and you will not have to start from scratch with learning teaching what mainframe and COBOL is. And you will be also able to convert your current COBOL team into .NET world. They will be able to learn .NET, and you will retain their knowledge of business and of system functionality. One of key assumptions is the coexistence. The coexistence actually means that the new and the legacy can work together in a consistent way. So before you start the project, you have transactions, batches, and database, everything on mainframe. Under the coexistence mode, you can gradually migrate your transactions from mainframe to the open world. You can do it week by week, move groups of transactions from one environment to another one. And these transactions will be processed these transactions that you will move will be processed in a Windows environment while still operating on mainframe database. This means that the Windows transactions can save the data in mainframe database, and they will be immediately available for mainframe transactions to be read, and vice versa. At the same time, what has been saved by a Windows transactions will be available for mainframe batches for processing. So everything is done together in a consistent way, and the legacy and the new can coexist. In the second phase, you start to move batches from mainframe environment to the open world. And this works pretty much the same. So what has been, processed by Windows batch will be immediately available for next batch in the mainframe database for processing. Finally, you migrate your database from mainframe to Windows, and all your system is replatformed and available in the new platform. Why are we following this coexistence pattern? First of all, it allows us to convert Big Bang into a phase launch of business functionality. So we can have early production verification, which is very important and prevents you from enabling everything on one day and keeping fingers crossed that everything will work well. Second is that you have a fallback option. So if some transaction does not work in the new, you simply switch it back to mainframe, you fix it, you test it, and you switch it again to the open world. And then you see if things work well. And the last thing, you can optimize the CPU usage. Once you move transactions away from mainframe, your CPU usage will fall down. Since coexistence is very important, I would like to deep dive on it and introduce a switch concept to you. So before we launch the project, our CICS transactions were exposed to external world as it is shown on the picture. So we had a communication server that was processing web services, and once it was the time to call CICS transaction, the Microsoft Host Integration Server was called. Then the Microsoft Host Integration Server called CICS transaction, which utilized the data from DB2. I would say a pretty standard pattern for the mainframe world to expose CICS transactions through web services. During the project, we introduced a switch. So a switch is a part of the software in communication server that decides whether we should follow the previous path or whether we should enter the new. The new means that we go to application server, we process all the logic, all the COBOL logic in the same way as we did in CICS, and then we retrieve the data from the same database through distributed data facility. In this way, with the switch, both paths coexist and are available for usage. Switch is truly a powerful tool. It's not, I would say, very complex, but truly enables you to test the new path in a very secure way. So first, you can specify that the transactions will be executed in the new only for selected clients or selected accounts, some kind of friends and family mode. This allows you to test, to verify on production the new transactions by your employees or by appointed external testers, and there is absolutely no risk that anything will be made public if in case of failure. Once you see that friends and family mode works well, you can start switching selected transaction by the transaction ID to the new path. You can do it for selected time frame so that you execute the new only in the time when your employees are at work, so that you can have the team for troubleshooting if needed. You can limit the traffic to selected channels, to selected client segments or product type, so that, for instance, corporate customers and the whole business customers do not experience any problems if they occur. You can also limit by transaction amount. And finally, what is very important is that you can set the redirected percentage. So at the beginning, it can be like 5 or 10%, and you can gradually get to 100% so that you set all the traffic for the new path when you see that it's working well. Another important assumption is one line of code. So our project assumes that we maintain only one line of code for both platforms. One line of code is compiled both for mainframe and for .NET environment. This approach allows us to deliver business changes and to release them in parallel to a platforming project. In 2020, we delivered over 20,000 man-days of business functionality, and in 2021, it was like over 15,000. So altogether, almost 40,000 man-days of business functionality in 2 years. Imagine if you had a project where you implemented a new system, then these 40,000 man-days would be actually lost, and you cannot really afford it. Under replatforming, every single man-day that you invested in your code will be available in Windows, in something new, which is opposite to the situation when you implement a new system. Also, one line of code prevents additional cost that is related to maintenance of two separate lines of code. You don't have any double coding, you don't have any double testing, double fixing, and so on. And last, one line of code allows us to do comparison testing. So this is a very effective way of spotting every differences between the platforms. With same inputs, you are comparing the outputs on on .NET platform, and you are comparing it with mainframe platform. And if you see any difference, that means that something should be investigated. So where we are as of now, and what is the scope of the project? So the project scope is consists of 4 streams. So this is online over 2,000 transactions, batch over 4,000 JCLs, database migration, and development architecture. In case of online, the replatforming is finished. Last group of transactions are to be activated in production environment. It is working well. The architecture is stable and is ready to process peaks of transactions. When it comes to batch, the batch replatforming is in progress. Partially, it's already on production. And these batches that are on production do not influence the time of end-of-day processing, which is maintained as it was before. The data, when it comes to database migration, we have initial data conversion engine, it's delivered, and we have created several environments with new database, and we tested online transactions, and majority of online transactions work successfully, and they were tested on target database, of course, in testing environment. Last but not least, development architecture. So first we had to create a mechanism which allowed us to synchronize the code from mainframe to Git. And then based on Git, we were able to compile, build, release, and deploy the application to the Windows environment. Now we are working on reverting it. So we want the code master to be stored in Git and then synchronized backwards to mainframe so that it can be compiled and deployed over there. So to sum it up, replatforming enables smooth transition by the following. Repeatable process, so you have automated conversion, interpretation, compilation, which is secured by Raincode compiler. You are harvesting the experience from all other installations and projects, which is embedded within the Raincode compiler, and this is done automatically. The coexistence assures the smooth transition by the fact that one big decision is split into many smaller ones. So instead of having a big bang, you have multiple decisions that are far easier to be made. Comparison testing. So again, this is spotting platform differences at low costs. And automated testing. So this is repeatable testing that is also performed with a low cost. Online switch. So this is what we talked about. You are able to fall back in case of any production issues so that you can fix it and bring back to the new world. And it's not, I would say, visible as in case of a big bang. Same thing about batch switch. And of course, database migration fallback in case of any production issues. So thank you very much. I could talk for another hour or two since I'm a fan of this project, but the time is limited. But if you want to hear more about replatforming, if you are considering how to migrate your software from mainframe to the open world, I would be very happy to meet with you and spend some more time. Thank you.
Hey, Pierre, thank you so much. It's been absolutely wonderful. And as I mentioned before, we will take questions after the presentations. So without further ado, it's my pleasure to introduce Pierre Milet, who's the domain solution architect at Microsoft Industry Solutions. He lives in wonderful Madrid in gorgeous Spain, so he enjoys the good time. Pierre Milet, buenas tardes, and the floor is yours.
Buenas tardes, good afternoon, and good morning for the Americans. So let me share my screen. Yeah, so should I share my screen? Sorry. Okay, could you see it?
Yeah, Pierre, we good?
Yes. Okay. So let me present you the Asisa case. So this is a project that we did for Asisa, a health insurance company in Spain. And this company, what we did was to modernize, so to migrate one of their legacy business critical application workloads to Azure. So what we did really is very similar to what Uli was explaining at the beginning. So we moved the legacy application into a cloud native, fully cloud native environment, running on Kubernetes, and also using DevOps for all the continuous integration and continuous deployment processes. So during this presentation, I will talk to you about the strategy, how it was the strategy that we follow, and the decision that we take for that. And also we will talk about the solution architecture. And then I will show you a quick demo about how the full end-to-end process, so you can see how from COBOL code until we get deployed into a container apps. In that, actually, we have a sample that also show how to move COBOL into a container apps. So this slide it's funny. I like it because it shows the evolution of the mainframe, no, since the 60 or 70 until today. So we have there is many stages, no, around the way, and this spaceship that you see is our solution. So this represents our solutions, and what we are able to do is to take. Inside our spaceship, we will take a jewel, diamond, that is your more valuable asset, that is your COBOL code, and we'll bring it into a cloud native environment. So we are going to travel 50 plus years of history in a moment. No? So this is just to make reference to Star Wars movies. And then here it's a representation of the different, let's say, strategies that you can follow. No? And from in the bottom left is the no strategy. So that it means you do nothing. You stay on the mainframe with your COBOL code and your DB2 into your monolith. The second option that you have is to expose some of your transaction to the outside world through APIs, through REST APIs. So this is something that you can do. IBM has also a solution to convert some COBOL programs and publish REST JSON modern open APIs. And this is exactly the situation that we found when we started this project in Asisa. Asisa already did this step, so they already was publishing their mainframe application through an API, but the application is still running on the mainframe. So the second option that you have is take the code as is, lift and shift, compile it, and put it all together into a container app, into a container solution altogether, and with a single database. And the next strategy is that the one that we follow, it's what we call the transform strategy, is that we take this COBOL, but we decompose it. We decompose it if of the business transaction is independent transaction. And then also we are able to create new transactions or new microservices aside in C#, in Java, in whatever language we like. And thanks to this Dapper solution, we are able to interrupt with our COBOL legacy application and their new technology stacks development. So we really, in the transform stage, what we really have is a complete homogeneous solution where COBOL developers and C# developers and Java developers can work together using the same patterns and practices. Then we have the last is the revision. The revision is what we call a total rewrite. So you start from scratch and you rewrite everything so that you can rewrite in any language. So what we recommend is the transform, since it's a fast track to cloud native. So the main milestone that we follow at Asisa was we started with a high-level assessment of the code just to quickly have a grasp on the complexity of the solution that we were trying to sell this project. Then we did a technological POC just to demonstrate that the technology was doing what was expected to do. So we took one transaction, we migrated to .NET, and we were able to execute it. Actually, we executed in as ASP.NET application or as a function. So we were able to show the customer that this technology was okay. And then once the customer was okay and was confident about what we were able to do, we started the migration of one of their workloads. So the goal here is not to migrate the full mainframe, is to start with one workload that we identified as a workload that was not too small, not too big, and that represented like a 20% of the mainframe. And this workload is called Professionales. And we did all during this project, let's say, piloting of this Professionales, we deployed infrastructure in Azure, in the Kubernetes. We also set up all the DevOps pipelines and DevOps infrastructure, and we migrate the code and we deploy it into production. So since September 2021, this system is in production without any issues. And now we are starting the second part that will do the full migration. So the idea is, by doing this MVP, is to get the muscle and the practice about how to do it. And then with this knowledge, we are able to do the full scale migration more quickly. So this is an iterative process and very agile mindset. So here is let's say the conceptual architecture. So we have in blue is the legacy and the green is the new things. So we have a user interface that we don't touch. So one of the goal was don't touch the UI. The UI is still connecting to the WAS, the WebSphere application server. And then we have a request dispatcher, very similar to what Pierre was explaining, where we can redirect the calls to the previous IBM IP gateway or to the new Azure API management. So what we did is create an API that was totally conforming to the IBM API gateway. So that in that way, all the calls from the UI work also in the new system. So we're able to execute the same transaction against both systems. And this was done like it's what we call a dark deployment, a dark launch deployment. So we execute in production, we execute the green line, and then in the background we re-execute the request, and we keep all the response that we receive from the legacy and the new system, so that after that we can examine or analyze the response and looking for difference. And if we spot a difference, then we can troubleshoot it, try to see where is the difference and why there is a behavior that is not the same. We also, during this project, we also moved to DB2 and SQL Server, and also we use a change data capture solution so that the data was replicated in near real time. Okay, so this is the final reference architecture. There is a a part in the left, in the right, in the left bottom side is the DevOps, all the DevOps logic. So you have a unique user interface, IDE, sorry. And then we move the online application into Kubernetes, and we also migrate the batch, and we also have some routes to the on-premise backend just for the data, copying data and moving data from the on-premise to the batch. And so this is under the cover. We use Dapper, Keda, Prometheus for the metrics, so on. So this is a little bit a summary of the decision that we took. So first, we preserve the COBOL code for online and batch. We don't touch the COBOL. So this is the COBOL still COBOL, but running into a modern user development environment like Visual Studio, and with all the tools that Visual Studio has, like debugging, so on. This COBOL code is shared between the two systems. So we deploy the same code in the mainframe and in the new cloud native system, so that if there is some difference, so we don't never diverge. No, so this is very important. We also respect the existing ABM API schema, so that in order that we don't have to change the user interface. In the user interface is using exactly the same API contract it was using from the beginning. We deployed all this solution on an existing Azure and DevOps environment that the customer already invested some years ago. So also we have the chance that they already have made some investment there, and they were already using this, so they already have some kind of knowledge about DevOps and Azure and so on. So this was also a good thing. And we reduced that infrastructure, so they didn't have to invest more. So they just maximized their current investment. We also adopted a cloud native and development practices for agility and innovation. So this it's also one of the goals, is to reduce the IT skill gap between COBOL developers and C# developers. So when we did the project, one important part of this project was also the transfer knowledge, to the COBOL developers. Now they are going to start working in a new environment they are not used to, and they are going to start making commits, push, tests, and things like that. But they will still develop in COBOL. They will still maintain their COBOL application in COBOL, although they can create new application or new functions or new programs in other language, because now everything is .NET, everything is cloud native. The process of migration also has been, it's a quick and industrialized code migration process. So since we don't touch the code, the code is automatically migrated, and also is automatically deployed into target environment. This is something that I will show you in the demo. And then also we move the data to SQL Azure just for performance, since the SQL Azure is running side by side near the cloud native environment. So also we allowed some architecture improvements, so that to make that the database was so near to the runtime, the cloud native, the Kubernetes environment, so that the latency was minimal. Also, we have it's obvious also a cost reduction, and also we are able to unlock some business intelligence. Since we have the SQL Azure, we can take advantage of all the good tools that we have for that. And then from a deployment and testing strategy, as I mentioned, we did the dark launch, that is recreating the request from on-premise. So during a time, this is a phased approach, so that there is a time both systems are running side by side. And then also we can do like a blue-green. Blue-green means that we can switch back to the mainframe or switch to the new system in case of fallback or any problem. So this was the main, I think, more important decision from a strategic point of view. And at the end, what we were able is to roll out to production. So this took like eight months of work. This was very important because we did this with a small, agile, cross-disciplinary team with people from Asisa, from Microsoft Industry Solution, and Raymond. And it's very important to create these synergies between the customer, the tool vendor, in this case Raincode, and we were acting as Microsoft as integrators, and also the one who knows about the cloud native and Azure. So now Asisa is in the position to quickly deliver new business capabilities in the form of new microservices, and also he can leverage and extend their existing legacy business capabilities. And this is the sentence when we finish the project, when we put it in production from the CTO. And he told us the rollout to production has been a success. We only suffered the typical delays and some minor incidents, and the performance is even better than expected. And this is true because the performance, since now we have this auto-scaling capability, this is a big change from what they have previously. So I will ask Alex to launch the demo recording I made this morning with a sample that will show you the end-to-end. So go ahead, please. I don't know if I exceeded my time or not. In this demo, I want to show you a full end-to-end process to develop a COBOL application and then publish it as a API ASP.NET Web application into a container apps. So the process, the end-to-end process starts with the coding. So we make modifications into our code files. We push these changes into our repository. From there, the files are compiled using the Raincode agent compiler that will produce assemblies that will be packaged into NuGet objects and deployed into the DevOps artifacts repository, where we have all the different artifacts. In a second step, we take this code and analyze it and generate code to generate a ASP.NET Web API REST API for this COBOL application. So we are able to understand how the COBOL is built and automatically generate a specific schema, API schema to be able to invoke this COBOL application from the outside. Then we take this ASP.NET Web API generated code and we publish it as a container into Azure Container Registry. And from there, we are able to deploy it to the container apps environment using infrastructure as code scripts. And then once deployed, we can test it and see if it's behaving as expected. So let's go to the next slide. Is just to illustrate all the steps. So the COBOL sources, then the compilation to the Raincode agent, the generation of the artifacts, the API code generator that also generates a new branch into the checking accounts of API. That then we merge with the main and we generate the Docker image and then publish into the container apps solution. So let's go to the code and see the process end to end. So here I have a COBOL application that is called getBalance. I also have a .NET C# application that it's a test application that invokes this COBOL application. So if I execute this, you can see also that the developer experience we will have the same developer experience in COBOL that in C#. Actually, we can execute from COBOL to C# in the same session, and we can do whatever we usually do in the debugging session, step-by-step execution or looking for the value of the variables. If I continue, then I come back to the C# application that call it and can see the result of the execution. Here, the account ID 1 has a balance of 200. So my application, it's already deployed in Azure. So, for example, here I can. So I go to the Container Apps application. I click here to the link. This will drive me to the user interface of the API. that I just deployed. We have a create account, delete, deposit, get balance, get holder, so different options. And now what we want to do is add a new method here. So for doing that, we are going to come back to the COBOL application, and we are just adding a new program, a new COBOL program that we will call Say Hello. It's a very simple transaction, COBOL CICS transaction, that I will copy from a snippet. And now I want to make this Hey Say Hello also available into my web API. So once I saved, what I will do is execute my code generator application that will analyze the code and will do all the steps necessary to compile this code in my local machine, and then submit the code into the repository and trigger all the pipeline, the code generation pipeline. So here we are. So now what we can do is take a look to our pipelines to see if a new pipeline has been triggered. So this pipeline is the one out, is auto-generated code. This pipeline will generate two packages, one for targeted to with the same code, but one targeting DB2 and the other targeting SQL Server. So we can use the same different versions of the code depending on the target database. So when this finishes, it will create a new version in our NuGet repository of the last that will contain the just added Say Hello solution. At the same time, the code generator also has made a new branch for our with the web API. So if I go to the web API solution, I go to my Git repository, I will see a branch has been generated. So what I can do is merge this branch into the current branch, that is the main branch, so that I can take the changes in my main. In this case, since I added a Say Hello, I should see a new Say Hello controller appear. So this is the new controller that will allow us to invoke the COBOL code. And then also there is some code that has been auto-generated in the Say Hello folder, where we have all the logic that do all the handling and transformation of the JSON payload into a COM area memory, and also do the integration with the runtime, the Raincoat COBOL runtime. So once we have the code merged, we just need to update our package, our NuGet package, and for that we are going to look for the Raincoat package source and looking for changes. Once the compilation, the package compilation has finished, that is still ongoing. So we will stop the recording 1 second here and retake it when it finishes and continue. So here we are again. Our job has finished, so a new package should be available. So let's go to the web API, refresh to see if there is another package, and take the latest one, the version. So we update our web API solution. We accept. Okay, and then here what we can do is now save the changes and commit and push. So updated. Commit and push. So this will generate the ASP.NET Web API image into a container apps, into a container. solution. And in this first stage, and in the second stage, it will deploy it to the container apps infrastructure in Azure using infrastructure as code. In this case, it's a bicep technology, and then once it's finished, we can take a look and test if the application is well deployed and working as expected. So now that our application has been generated and deployed into the Kubernetes and to the Azure Container Apps environment, we will see here. I can refresh. We can see in the revision management if it's been published, correctly provisioned, as you can see here. And then let's again navigate into the Swagger and let's see if our new say hello transaction is available. As you can see, it's there. You can try out, execute it, and check and test it's working as expected. As expected, we will receive a response with the message, "Hello, folks." So this is the demo. We have also just added notes as side notes that we have also application insights, all the application insights functionality, so we can look at all the traces generated by this application. So for example, let's look for the last 30-minute request. And for all the traces, as you can see, we have different information here available. We also have an application map so that we can see all the instances. So for example, for the last 30 days, we can see all the things that have been happening in the solution. We also many applications, so have all the information available here. And then other scenarios or demos that are not covered here, but one of them is this one is calling between inside the same application environment, checking account API COBOL application being able to call a Java application that represents, for example, the customer's microservice. And all of this is done transparently using the Dapper runtime that is part of the Container App solution. And we have the log analytics application insights functionality out of the box. And this is the batch runner. The batch runner is also something that we have in this in the demo. It's a container that is running on where we are running the GCL runner, and we are able also to dispatch jobs that are executed inside this runner image. And all these images are mapped to files that are mounted in Azure file volumes and so on. But this is for another demo. Thank you for your time.
So, Pierre, thank you so much. I hope you can all appreciate that I wasn't lying when I said that all those projects look different, and we aren't to the end of this yet. It's my real pleasure to introduce Raymond Diaz, who I have to read the title because it's an impressive one, Lead IT Business Analyst at Duke Energy. Raymond, how are you doing today?
I'm doing good. How are you, Darius? And thank you for this opportunity.
Respectfully, I'll feel better in half an hour when this will be done and the stress of organizing this will be over. But thank you for asking. Thank you for asking. So listen, problem. Duke Energy is a household name in the States, but for all the people who've joined from all over the planet, can you tell us a little bit more about the organization?
Absolutely. Duke Energy is publicly traded on the New York Stock Exchange, primarily a utility company. It belongs in the Fortune 150. It's headquartered in Charlotte, North Carolina. Our fleet serves about 9 million households, as well as we generate electricity from hydro, coal, oil, natural gas, solar, nuclear, and wind. And I am part of the nuclear generation group based out of in the US and South Carolina. So we have 6 nuclear power plants, and that's the team which I support.
Okay, can you tell us a little bit more about yourself?
Yeah, like you said, I work as a lead IT analyst at Duke Nuclear. I am primarily responsible for the business needs and the technology needs of the groups that I support, namely engineering and a few more. But having said that, I've been in Duke for about 6 years. Prior to that, I used to be in the ERP world, and I've always been on that bridge of technology and business where those two meet, primarily because I enjoy technical stuff and I love learning business stuff. So, and I enjoy actually bringing business and IT services together so that we can achieve success.
Yeah, we've learned the hard way that nuclear energy is like critical and serious and very hush hush. So, but what can you tell us about the application?
Yeah, it is what you heard is true, and it's basically we have this application which basically has information about all the cables on a site. Cables being different types, different voltages, different parameters are there for each cable, the weight, the size, the looks, feels, color coded, everything else. So all those kind of information is held in this simple software, which was created in 1970s and has been used daily since then. So it is a very critical piece of our usage on a day-to-day basis because we need to know what is where before we do anything else. So that's where that comes from. It's not a very large application, but it's an absolutely critical application that we use on a daily basis.
In terms of infrastructure, so I'm not going to ask phony questions when I know the answers, right? So, but please correct me if I'm wrong. It uses vSAN for storage. It doesn't. It's a bit too old to actually use a relational database, and you use CICS and green screen and BMS maps for the user interface. Is that correct?
That is correct, and actually, by implementing this solution, we maintained the vSAN structure as well due to time constraints. But it was awesome because we also retained the green screens. Everything was a lift and shift.
Absolutely.
Yes, we faced a little bit of errors here and there, but as we went along implementation, we did all that. So.
It is the very opposite of the kind of approach that Pierre described before, where you take the application, you cut it, you slice it, you break it, and you put it back again in a different shape. You kept it really as it was.
Absolutely, because of course we had different goals. Our primary trigger was pretty much bring down the cost and get rid of the mainframe. So moving from that direction, we got our cue to, hey, we got to keep this minimum, no changes, lift it, shift it, move it away from the mainframe. That was the, main focus with keep our business continuity going, very minimum user interaction, no user training at all. Though that was the background which we based this on, and that's how we kept what was there. Yes, we had to do some changes, tweaks here and there, because as we all know, 95% of the code will compile successfully, but that 5% will take the other 80% of your time. So
yeah, and if I understand correctly, that this was not your first attempt, right? You've tried. I mean, you not necessarily personally, but you as an organization, you've been trying to move this thing out of the mainframe for a while, haven't you?
Yes, this effort has been coming on and off for a couple of years, actually, maybe about 8 to 10 years prior to me joining, and it has failed on multiple times. It has failed about approximately 3 times, and there were a multitude of reasons. The technology was not right, the cost was too high from the vendor, as well as the right resources were not available. So we we were pretty unsuccessful historically, and that was my I was given that heads up before going into this project. So it was I had to approach it with a totally new mindset, and that's where we went through with Raincode.
And now that it's done, how does it feel? I mean, how does it feel? What's the feedback? What's the future? Where are you now with this application?
Oh, it's amazing. As long as no tickets are created, nobody calls. IT always loves that, right? So that's what we have going on. We don't get anything from the system. The users are extremely happy. They came on a Monday morning. They didn't have they logged in as usual. Everything was fine. In fact, one of the best compliments which I personally like is when the original developer who was there in the 70s, he's still on site and he still works with the product. And he gave us such a high compliment that he did not expect this to go so smoothly. So that was, that was like the icing on the cake for me. Actually, it was the cherry on the top. We did get a lot of compliments from the business leaders, from the managers, primarily because they had known the history of this application.
So we all can imagine, the financial benefits and because that was the business case, that's what drove this. But any unexpected benefits, something says, oh, this is really cool and nice, but we really did not expect this as a result of this effort.
Yeah, there were lots of hidden features initially when we went through the SOW and all that. We didn't have a whole bunch to work, but as we learned the application, how to use more and more, there were certain programs which were not able to, we never got them working, and then using Raincode technology, we were able to get them running, ability to print and things like that. So there was initially, although that was out of scope, but as we moved along, we say, oh, there is so much of stuff over here we can use, and then we started using that. So that was really unexpected from our end.
So you have to appreciate that everybody's really listening to you because you are on the other end of the fence they all want to go through, right? You've done it and you are off the mainframe. Any word of advice, any word of caution to anyone who would consider doing it?
I think, and we had done that before, like knowing what you have to migrate, as well as once you have that list and you work with the technical folks at Raincode, the training that they provide, that you have to learn that product so well because you could miss out on features that are there. So basically my thing would be to really understanding the Raincode product to see what it has, what it can do, and go from there, because knowing that will speed up your implementation as you go along. That's been my personal experience with working on this product.
Hey Raymond, thank you so much. This has been really great. So you see, it's a journey, but you can get there. And for how long have you been off the mainframe by now?
We went live on August 23rd of last year, and I'm proud to say that we've not had any issues, man. That's like that's amazing. So yeah, we went August, so it'll be a year now. So everything is pretty smooth, and you know how we say in IT, as long as no news is good news. That's our nuclear motto. As long as there's no news, that's good news. So that's how we take it.
Hey, wonderful, Raymond. Thank you so much. This has been really great. I think we'll switch to questions. So, if you'll allow me, there was a general question raised about about what do we do. I mean, and that was a question raised mentioning one of our competitors' product by name, and if it's okay with you guys, I will not, just for the sake of it. But the question is, what do we do in terms of analyzing assets and ensuring that they measuring their quality, measuring their ability to be migrated, and so on and so forth. So what we do in that area is that instead of having a separate analysis tool, instead of having a separate product that is going to be responsible for looking at the assets and gathering facts out of these assets, we took a totally different approach. What we do is that our tools, our compilers, our emulators have the ability, whenever they process any kind of artifact, whether we talk about source code or IMS DVDs or BMS maps or whatnot, we have the ability to populate a repository database where all the interactions and all the relationships are documented. And under the name of Raincode Insight, we then provide a number of Power BI dashboards that give us tons of information about SQL usage, CICS usage, how well do programs compile, the split across languages, and so on and so forth. So we have very much an approach where instead of having a separate product, we use our own products to gather the information, and we use Power BI to produce dashboards. So there was a question raised, and I think that is pretty much in sync with what both Piotr and Pierre were mentioning, namely the fact that there is a coexistence period. And the question was raised whether this was in line with what we did in due time for SDC, which is one of our biggest customer based in Denmark. And at the same time, yes, because this paradigm of doing incremental migration is something that we did not come up with. It was literally, almost literally, whispered to us by SDC saying, you should do this. This is what we actually need. And it's a paradigm that we've been reproducing in a number of instances, including the Piotr's project, including Asisa with Pierre. But there are always significant variations. The way you organize incremental migration can be very, very different. I'm sorry, I'm really useless without my glasses. Okay, I have a question. Piotr, I think this question is for you. What tool do you use to compare the mainframe output and the rehosted versions output?
The custom one. We wrote it.
So you built your own infrastructure to ensure that the rehosted application behaves like the original one?
Yes.
Okay. Is there a specific reason?
Basically, we compare, we download the outputs to our tool, we compare it, and then we have the discrepancies that need to be analyzed. Okay.
This is perhaps more for Pierre. Is there a conversion in the schema, or when you go from DB2 to SQL Server, are your schema isomorphic?
Okay, I also will answer the previous question, because we also did something as Piotr. And we were able to build also a tool that was able to take the response from the legacy and the new system and be able to compare, if we find any difference. And we develop a tool as part of the project in order to pinpoint the difference and then be able to do the troubleshooting in case of we find any behavior, different behavior. So as Pietro said, also we follow the same strategy. So we build our own tool. And I recommend that because also all the customers will have different scenarios. I don't think there is a tool that is able to do that automatically, so it's better to have some of the domain knowledge in there. And the second question about the DB2 and SQL Server, what we're using was the functionality that Raincode provides out of the box. So when we compile our code, we compile it using a flag that indicates that we want to use the DB2 runtime or the SQL Server runtime. And the code is the SQL code in the COBOL is not modified. It used the COBOL dialect, but then under the covers, the runtime will convert this to SQL Server. So when we migrate the DB2 to SQL Server, we do a direct migration and we have an equivalent schema as the DB2. Actually, in the first stage, we migrate the code against DB2 We test that everything works. So both systems are going to the same DB2 database. And then when the code is okay, is working, then we do repeat the test, but against SQL Server. So this was also the strategy that we follow. That we make it in 2 stages, not the verification.
Pierre, given the size of the system, there are essentially 2 questions that are deeply correlated. The first is that we would assume that sorting data is a significant part of the workload, and if so, how did you address it?
Okay, in fact, sorting data, or I would say operations on file, is a big part of our batch processing, and the solution for it was utilizing the DMX Express software provided by Precisely. So we have a separate server that is doing the sorting, and all the commands related to sorting or creating reports based on sorting, summarizing, and so on are redirected to that server. There is also a part of the job that is done by Raincode. So the native ICE tool, Iceman, DF sort syntax is translated to DM Express syntax by Raincode.
And more generally, when we look at a project of that magnitude, any comment on performance in general? How do you address performance? What is the biggest performance challenge you have?
I would say the biggest challenge from the... I understand we are not talking about sorting, but in general, the system.
Yeah,
right?
in general. Yeah, sorry, in general.
So the biggest challenge here is about the fact that if you step off the mainframe, your database and server and application server are no longer the same server. So on mainframe, the CICS and DB2 are on the same machine. The data are transferred through the memory, so that's really very efficient, fast. And if you get off the mainframe, your database server will be in a separate place compared to application servers. So the road to database is far longer, and this impacts your application processing time. So this is what we are working heavily on. A lot of things are done here. We are doing caching, SQL queries optimizing. We are parallelizing we are making our batch process working in parallel streams, so that instead of having one stream, quite a long one, we have several working together in parallel, and therefore achieving the same processing time.
Thank you. Yeah.
Yeah, I have also, I will also say something about what we found about performance and also some interesting conclusion that we get. No? So for the online, in our case, it was okay because the online transaction, it's a code that doesn't do a lot of trips to the database, but in the batch we found, and this is because the code was written like that, there was so many, was very chatty with the database. So the way we resolved that, for instance, was migrating the DB2 to SQL Server, so that the SQL Server and the Kubernetes system can be together. For that, we also used some of the features that we have in Azure, that are the proximity placement groups, so that you can ensure that the database server and the Kubernetes server are in the same network, so that the latency is low, and then for some specific batch, very long batch, we were able even to execute. Even we executed in worse performance than in the mainframe. The performance was good enough to fit in a window, in a batch window, because the batch is something that is executed offline and normally doesn't have the same requirements from a performance point of view or response time point of view as a user interface solution. So in our case, we were okay because the windows where this batch should be executed was good enough to execute it on time.
Hey, thank you. Raymond, last but not least, but it's my last question for today. Now that your application is of the mainframe, I appreciate that this application is, well, almost as old as I am, which doesn't make me feel very good about it. But do you have modernization plans for the future?
In the near future, there is not any plan, only because everybody's still basking in the joy of this thing working smoothly. So nobody has even thought about it, but probably I would personally like to see it going into SQL Server and then, enhance and use the data and use the information that is there in a much better manner, or, use all the other things that we do with analytics and all that kind of stuff. So right now it's like standalone, doing its thing, great. And as soon as the honeymoon is over, we'll be like, okay, let's emphasize and go to the next level using the same information that we have.
Raymond, thank you. So listen, it was wonderful. Uli, Piotr, Pierre. I confused Piotr and Pierre for obvious reasons. So Uli, Piotr, Pierre, and Raymond, thank you so much. This is it. For all of you who attended, thank you so much again for attending. A number of additional questions will be taken offline because of lack of time. Other than that, all the material, the videos are going to be available, and an email will be sent shortly with all the relevant information. Thank you so much, everybody. Have a wonderful, wonderful day. Bye-bye.
Thank you. Bye-bye.
Thank you. Bye.
Thank you.